Hello and welcome to Call of Chemistry. In this video, we will discuss some tricky problems regarding plane of symmetry, center of symmetry and alternating axis of symmetry. So let's start. So in the first problem, it is told that which is true for the following compound. So we have to find the true statement about the compound. Before we solve this, we have to learn some basic things. Suppose A is a group whose absolute configuration is R and we place a mirror, then the absolute configuration changes to S. This is mirror. And suppose this system is taken. Here is H, here is AR, and here is AS. Here A represents a group whose absolute configuration is R and here is the absolute configuration is S. This system contains center of symmetry because if we consider a point within the molecule and we move equal and opposite direction from the point, we get the similar type of ligand with opposite absolute configuration, that is R and that is S. And similarly here also this is R and this is S. That is why center of symmetry also called inversion point, that is the absolute configuration get inverted like that. So the criteria that a molecule possesses center of symmetry will be if the point within the molecule and if we move from the point equal and opposite direction, and if we get the same type of ligands with opposite absolute configuration, that means the compound contains I. So back to the problem. In order to solve the problem, we firstly assign the RS configuration of these asymmetric centers. So this is 1 and this is 2 and this is 3 and this is 4. So it will be 1, 2, 3. It should be S, but as hydrogen is placed in the horizontal position, so it will be R. Similarly, it is 1, it is 2, it is 3 and it is 4. So it will be also it will be R, and it will be 1, it will be 2, it will be 3 and it will be 4. It will be also R, and it will be 1, it will be 2, it will be 3 and it will be 4. So this is also R, and we simply generalize the compound such as we represent the whole group by A and its absolute configuration is R. Here also it is AR, here also it is AR, here also it is AR. So the first criteria tells if a reflection operation is carried out, then the absolute configuration of the group will be inverted. If a sigma plane were present, then it should be inverted, but it should be same. We will see that the absolute configuration remains same. If a sigma plane would be present, then it should have different it should have opposite configuration. If it will be S and it will be R, then sigma plane will be present, but here sigma plane is absent because the absolute configuration is same. Here also it is R and it is R, so there is no sigma plane. Sigma plane is absent. And if we see the second criteria, if I present in the molecule, then this ligand should be R and this ligand should be S, and this ligand, if this ligand is R, and this ligand will be S. But here if we assume a center within the molecule and if we move equal and opposite direction, we will get the same ligand, but their absolute configuration is same, that is R. Here is R and here also is R. So here inversion point is absent. Also we see that here is R and here is R. Also absent. So the correct option will be option number 4. Now we move on to alternating axis of symmetry. That is represented by Sn. In order to solve problems corresponding to Sn axis, we have to keep in mind that two things we have to keep in mind. These are S1 is equivalent to sigma and S2 is equivalent to I. So if a molecule contains I, then it must contain S2, and every molecule containing a sigma plane must possess S1 axis. So we move on to the next problem. Here the problem tells which is true for the following compound. That is sigma plane, first option tells sigma plane is present or S1 is absent, I is absent, or S2 and I both are present. So in order to solve the problem, simply we have to find out if there is I is present or not. If we consider a point and within the molecule, and if we go equal and opposite direction from the point, we get that two groups we found and absolute configuration are inverted. Here also it is AR and it is AS. So here I is present. That means S2 axis must present. We will explain that. Suppose we draw axis, and according to axis we operated 180-degree rotation, that is nothing but C2 operation, and upon C2 operation this AR group will go to this position, and this age group will go to this position. This AR group will go to this position, and this age group will go to this position. Simply we can draw so here it is AR, it is H, it is AS, it is H, it is AR, it is H, and it is AS, and it is H. Now, from the definition of alternating axis of symmetry, we get that rotation followed by reflection, and reflection is such that the reflecting plane must be perpendicular to the rotational axis. So here we consider it is the rotational axis, so the reflecting plane will be perpendicular to that of axis. So the reflecting plane is such a way. So upon reflection, AS will be here, and we see that upon reflection from the first criteria, that was AR AS. So from that, upon reflection, it will be AR from this, and the hydrogen is here, and the hydrogen is here, and it will be converted to AR upon reflection. So here also it is AR, and it is H, and it is AR, so it will be AS, then it will be turned to AS, it will also AS. So here it is AS, and here it is H. So we find that this compound and this compound is identical. Is here it is AR and H, and also here it is the same position here in H. We can see that here is H and AS, so here also H and AS, here H and AS, here also H and AS, and here AR and H, so AR and H. So these two are identical, that is this compound contains S2 axis. As C2 is operated, so its corresponding fold will be 2, that is S2 axis. Now what is the second criteria? We have told that S1 is sigma. So S1 is sigma means that molecule containing sigma must contains S1 axis, and that molecule doesn't contain sigma must not contain S1 axis. So here in the problem we can find that there is no sigma plane, because we have discussed earlier, if there was a sigma plane then the absolute configuration will be opposite, but here the same it is found. Here also R and here also R, and here also S and here also S. So there is no sigma plane. In other words, we can say that this compound lacks S1 axis. So the correct option will be S1 is absent and S2 and I both are present. So by here I am stopping this, and please like, share and subscribe my channel. Thank you.